Hi everyone, this is Christian Proto. I'll be the one presenting the software today. If you have any questions, we will not be able to answer them during the presentation because there's too many people connected. But after the presentation, I'll be sending an email to follow up, and you'll be more than welcome to reply to this email with any questions that you've taken down during the presentation, or to receive the link to be able to play back that presentation that we're doing today because it will be recorded. I have my colleague, George, who would also be attending the presentation, and we'll be able to answer some of your questions if you have them. So first of all, I would like to know if everyone sees my screen and can hear me. So if you can just like put a little message or, okay, yes, perfect. So I've received some replies, so thank you. So we will start the presentation. And then, like I said, we're going to go today through a hydraulic circuit. We're going to control this circuit using electrical control. Then we're going to do a little pneumatic circuit control with PLC. And afterwards, we'll be creating a resistive circuit and a motor control circuit. Keep in mind, this is a basic introduction to Automation Studio. So we're going to keep our schematic pretty simple and showing you at the same time some tips and tricks of Automation Studio. So to start with, first of all, this is the library of symbols that should open once you're going to open Automation Studio for the first time. This is where you're going to have all your components. If for any reason this library is not there, okay, if I close it and you can't seem to bring it back, this is the icon that you need to go through, Library Explorer. This will actually reopen the library like this, okay? There is a little pin here, okay? If you uncheck this pin, it will auto-hide the library on the side. If you go over it, it will bring it up. And if you go back, it's gonna close, okay? So personally, I prefer to have it always open. So I'm gonna click that pin to make it stuck there. The library, the interface of Automation Studio is based on Windows applications. So you have all the main category here that you can select from, and the icons will adjust to whatever you need. Same thing if you are working on the software, this will auto adjust as well. Okay, so to begin with, we're going to actually create a basic hydraulic circuit. The library is pretty extensive. If you can click on the little arrow here, it will open subsection of this library that you can navigate through to find the right components that you want. But for the presentation today, all the components we need are basically at the root of this library. So the way it works is quite simple. You simply click on the component that you want. You keep your finger down on your mouse and you let go to drop it on your schematic. So I'm going to take like a reservoir, put it here, a pressure relief valve, put it here, a double acting cylinder, and then I'm going to take a 4-2 directional valve. Once I've placed the component, you see if I move my cursor over a red dot, it changes a target sign. That means that you can create a line there. So you're going to click on your mouse, on your left mouse button, click once, you let go of the button, and you click again. A lot of people have tendency to keep their finger down when they do the line. It is strongly recommended to let it go, and I'll explain you why afterwards. So click here, let go, click there, click, let go, click. You see I'm a bit off, but components stay connected. So it's easy to just realign the circuit the way we want. Move that a bit here, click, let go, and click. I want to connect the pressure relief in the middle here, so I'm going to click here. But you see there's no target sign here. So the way to connect in the middle of a line, you're going to double click. And this will automatically insert a junction, like a T, for example. I'm going to connect this down to the tank, so I click here, let go of the button. But you see, I feel like it's going too close to my pump. So every time you click, you can make an elbow also. So click, click, and click here. Okay, so as you can see, as far as drawing goes, it's pretty simple. Then once you've done this, I'm going to go directly into the simulation section here and click on normal simulation. This will launch the simulation. So we can actually see here the flow going from the reservoir through the pump, exiting the pressure relief, which is open right now. And if you see, when I position my mouse over this lever, it changed as an and, meaning I can do something here. So if I click, I'm actually controlling my directional valve. If I let go the button of my mouse, it's kind of like the springs is actually pushing it back. So if I click and let go, it's going to come back. And you can see the pressure relief valve is also opening and closing. So it makes it very easy for students to better understand because they see the path of the oil and they see the component moving. Every component of the library is preset to work right away, okay? But for instance, you can also change properties if you want. So let's create a duplicate of that cylinder. I can take one from the library, or I can simply right-click on it, copy, and simply paste it here. I'm going to connect that in parallel with the other one. I'm just going to move it a bit and connect it from here to here. Double click, click, double click to insert the junction. So you see we automatically insert the jump over the lines as well. So now I want, let's say, that cylinder to actually push something up. So to do that, I'm going to go into the component properties. So there's two ways to go there. You can right click on the component and choose component properties, or you can simply double click on it. And this will open the properties window. In the data tab, this is where you can actually change all the properties of your components. So you can put the piston diameter, rod diameter, stroke length, weight on it. You can change all these properties and they will be reflected in the simulation. So let's put like an angle of 40 degrees and an external load of, let's say, 5,000 pounds. If you check this box here, it's because you want to display on the schematic this value. So once I'm going to close this box, you see the 5,000 pounds it's here. I can place it wherever I want. I can go to the Edit tab and actually change the visual aspect of this text. I can reduce the font. I can go here, change the color of it. And once it's placed, it will remain at that location. It is a satellite of the component, so it remains there. We inserted a 40-degree angle in the properties, but the cylinder remains flat. Because since we follow all the ISO standards, we don't turn components on drawing, but for teaching purpose, you can click on the component, you can go position, rotation, you can change the rotation point, and I can actually click on the corner here and just rotate my cylinder like that. The purpose of putting a weight and an angle, it's to measure the pressure required to lift this. So let's go back in the library. I'm going to put a pressure gauge here, connect this here, and I'm going to put a flow meter. Okay, here is how you can do this. If you drag this component directly from the library and you drop it directly on a line, it automatically cuts the circuit and connect. You see here, the circles are black. Black circle means it's well connected. If we do it again, let's erase that, and I drag it out on my schematic first, you see the dots are red because they're not connected. If I move it on the line, you see they remain red, means it's not connected. If the component is already on your drawing and you want to connect it onto a circuit, you hold the shift key down at the same time. So if I press shift and I move this over and I let go, you see the dots now are black. Same thing if you want to disconnect the component. You see, for example, you want to disconnect the pressure gauge. If I just pull on it like that, I'm just pulling the line. So to disconnect, I hold the shift key and I move it, and there's my it disconnected. Okay, so and then I can just bring it back to connect it like that. So this is just a manipulation tool. Also in the software, you see me move my circuit around. If you hit the space bar and you click on your mouse, you can pan your circuit. And if you hit the control key of your keyboard and you roll the wheel on your mouse, it zoom in and zoom out. And the zoom will happen, will focus, let's say, where you're pointing your mouse. So if I go on that cylinder and I zoom in, if I go on the pump and I zoom in, so this is something that could be useful. But then if you want to set everything back up in a nice zoomed, you can right click on your white page and you do zoom all component. And that will just bring it to a nice size. So now if I launch my simulation again, I see that I have 1160 psi in my circuit. You see, if I put my mouse over the pressure relief, there's a hand, meaning I can do something. If I click here, I can modify the pressure live during simulation. If I want to reduce the flow, for example, which is now 31.7 GPM, just a little note, in Automation Studio, you always have access to both unit, metric or imperial unit. So if you want to display bar, Pascal, PSI, you can select them. Same thing with the flow, liters per minute, GPM, you can just change it, okay? We have a way to establish that in your document, everything by default will be either imperial, metric, or imperial, or on each component, you can also change it. Okay, so it's always applicable. So for example, if you want to reproduce a circuit that was done in metric, you can put the metric value, and then when you're going to switch it to imperial, we will do the conversion automatically. So this is something interesting. Now I want to reduce my flow. So if I go over the pump and I click here, I can actually change the displacement of my pump or the speed of my pump. So if I modify the displacement, you see as I bring it down, my flow is going down in my circuit. And now if I start the simulation again, if I push here, this cylinder requires 16 psi to go out, but the other one requires about 280 psi because of the weight and the angle on it. And once I let go the button, it brings back, and this one comes back in, pushed by the weight first, and then the other one. You see, when I triggered this directional valve, I actually click on the lever here. You can also click directly on the spool itself. If I click here, you see I have a checkbox here. That means that it is mechanically overwritten. If I click on the other one, I'm just pushing it the other way around. If, for example, you had a solenoid here, and you electrify that solenoid, but the valve is not shifting. If there's a checkbox in it, it will never shift because it is mechanically overwritten, let's say. So to get rid of that checkbox, that check here, you click on any of the two commands. You see, if I click on my spring, it goes away. And if I click on the command here, it goes away also. And now that your valve has no check in it, if it would be controlled by an electrical solenoid, it will be working fine now. Okay? So this is how we can change, let me zoom all, we can change the properties of the components by double clicking on it. And we can also do the simulation. Every component in Automation Studio, if you right click on it, there's a context help, that explain about this particular component. And this applies for every component and every technologies. So you can select those descriptions, you can cut and paste, you do whatever you want with it. Okay. Also, if I select a part of my schematic like this, I can right click on it, do a copy, and then I can open Word, and directly into Word I can actually paste my drawing. And as you can see, the quality is great. I mean, it's all vector graphic, so it will print out very nicely. So for you to prepare assignment for students, or even for students to do reports, they can just cut and paste their work into Word, and obviously they can add the text that they want, blah, 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 you know? So for an instructor, what you could have done, you could have come here, taken only the components by hitting the Shift key and clicking them one by one. Then you can copy this and paste it into Word, and then the students need to do the wiring as an exam, for example. Okay, so the cut and paste feature is very interesting in Automation Studio. We did the simulation before, but we've seen pressures, flow, and things like that. But we can go a step ahead and monitor on the plotter what's going on through our system. So we have a y over time, y over x, and we have a 3D plotter. So let's take the y over time. I'm going to bring it here on my schematic. The way the plotter works, it's quite simple. Okay, if I click on that cylinder once, you see it is selected. Then I can simply slide it on my plotter. And once I let go the mouse button, it's going to ask me, what do you want to see? Okay, I want to see the linear position of that cylinder. Then I'm going to click on the other cylinder and drag it again. And I want to see on this one, the linear position as well. Then I want to see the pressure also in the system. So click on that pressure gauge and drag it on the plotter. I want to see the pressure. Then once I launch the simulation again, I can actually visualize now what's going on in my system by plotted curves. These plotters are also available for the pneumatic, for the electrical module. I can go backward again, and whenever I'm finished my cycle, I can just stop the simulation. I can just blow this up a bit bigger. I can click on this icon here to actually show the legend, and I can highlight the lines or even hide the lines that I don't want to see. And then I can also bring in, let me just zoom out a bit here. I can bring in a ruler like this, which has had a cursor. And wherever I position this cursor, I'm going to have a precise reading at that location. And keep in mind that also your plotter, if you click on this icon, you can cut and paste a plotter into Word directly. And you can export also the values to Excel, for example, to analyze them. Okay, so the plotter, as you can see, fairly easy, and then you can actually play with it and just export or just cut and paste into Word. It is a professional CAD drawing software. So for example, I can also insert a bill of material, a BOM. So I can just do a little square here, and it's compiling now the information of what's on my drawing, and it's going to display it on a bill of material that I can actually modify at will. If I unlock it, I can actually shrink it like this. I can double click on it, go change the field that I'm displaying. I can add fields. I can, it's really customizable the way you want. Okay, so this is right there. And if you drag more components, it's fully dynamic. They will automatically add to the list. Counterbalance valve, you see unloading valve here. Okay, and when you erase, it goes away. So this is something that you can very easily do. We can also insert references. You see here reference. If I click here and then I click on a component, I click again and I drag where I want the bubble to be. I let go. And then that could be, let's say, for an assignment of identifying the components, for example. And again, you can cut and paste that into Word, PowerPoint, or whatever application you want. I'm going to take them off. You see, when we simulated before, we added a pressure gauge, a flow meter. Obviously, if I go into the hydraulic and I go into the measure instrument, we have more measuring tools that you can use. Flow meter, integrating flow, a watt meter, think level gauge, thermometer, so a lot of different tools. But during simulation, you can also analyze your circuit by using the dynamic measuring instrument. Let me show you. If I start simulation and everything works well, but I would like to monitor the pressure at this point. Then I'm going to use in the simulation toolbar this icon here, Node Dynamic Measuring Instrument. You click on it, then you see a cursor has changed. And when you go to a connection point, you see it changes the target. So you click and you drag where you want to drop it. And here it's going to ask you, okay, what do you want to display? The pressure, temperature, viscosity of the oil, which unit you want to display it. So I could display a unit the same place I can display in PSI, in bar, and in Pascal, just to show students the differences, okay? And we're going to ask you to how much precision you want on your value. So if I want to show the pressure, you see it's displaying the pressure live in the circuit, and when I simulate, it will automatically update as well. If I click on the first one here, this is a component dynamic measuring instrument. If I click here, the cursor changed. I can click on the component. You see it became purple. Then I click and I drag to where I want to drop it. And I can decide to display the linear speed, for example, in inch per second. And I'm going to use a position of 0.1. So when I approve and I close, if I simulate, it extends about 4.65 inch per second. We track 5.9 inch per second. We also have a dynamic measuring for differential pressure. If I click on this one here, again, you see we always put on your cursor the item that you've selected so you know what you're doing. And this one works a bit differently. You're going to position it on a connection port. You click, you drag, you let go your mouse button, and then it asks you to click on the second node. I'm going to click here, and I'm going to display the differential pressure in PSI. So right now I can display that I'm losing in this hose 0.16 psi. And because we can change the size of my hose, the diameter of the hose to simulate pressure loss. And again, if I increase the flow in my circuit, I'm going to increase the pressure loss in that hose. So these are sometimes elements that could be hard to display on a trainer because all your hoses are almost like 4 feet long. So it's hard to use one that could be 15 feet long. In an automation studio, it's very simple. You can stop simulation. You can click twice on this hose and actually change the length of this hose to display 15 feet if you want. As easy as this. And when you close it and you simulate again, now you're losing 10 psi in this hose. Okay, so as you can see, the tool offers a lot of flexibility. Okay, and again, if I want to get rid of those, I just click on them and just hit delete. Delete and delete. Now I'm going to show you a function that personally I think is one of the best function of the software. It's the customizable library. Okay, like I showed you before, if you click on the little arrow here, it expands this library. And then if you click on, let's say, actuators, then you have single acting, double acting, telescopic, mechanically linked, brakes, motors. It could be overwhelming for students to find the right symbol. And the goal here is not to waste time for your students, it's to teach them the technology. So if you click on this book here, It says new library. So let me just save that here. I'm going to go on my desktop here. And let's save that and call it, say, webinar library. So you see I have a library called webinar. This could be the name of your school, the name of your class, you decide, okay? And in this library, I'm going to create a section, and I'm going to call it hydraulic. And I'm going to create a subsection to that. Click again on this icon, and I'm going to name it, let's say, Lab 1. If this is your Lab 1, you can simply click on the component and drag it in the library like this. So then your students can, for this particular lab, they can have all the components they need in a library ready for them to use to create the assignment. If you want to put more components to confuse them, be my guest and do it. But I'm just saying that at the beginning, it could be easier for them to go through a simple library like that than having to navigate to the main one. And if you change properties like on this cylinder, I can drag the cylinder in the library. I can also rename it. So I'm going to rename this, and I'm going to add here with 5,000 pounds. And you see if I drag it out, it keeps all the properties that I had put on this one. So if you want to have one of 5,000 pounds, 10,000, 15,000 pounds for students to see the differences, be my guest, you can do it. You can also select a multiple components like this here, right click, group, and put that in your library as one component that you can rename as well. Okay, so let's say, for example, you have an hardware trainer. And let's say FAMIC would have been the manufacturer of the equipment. We don't do any equipment, but I don't want to name any provider out there. But for example, if I click twice on that cylinder, I can actually give it the name. So component name, I can give it the exact same name as the component on my trainer. So let's say it's called CYL for cylinder and -A. I check this box because I want the name to be displayed on my schematic. And when I close, you see the cylinder A is here. As you remember before, we can change the font size and everything. And then I can create a section in hydraulic called hardware trainer. And here I have all the name, the components with the exact same name as the students will find them on the trainer. So when they transition from theory to practice, that makes it so much easier. Right now, these days, everybody works from home, so they may not have access to equipment. But, you know, I mean, a lot of schools do hybrid teaching. So they do half of the course online and some course in the lab. And this is perfect because it helps the transition. And if we move that a step ahead, let me open one of the library that I've created. So I'm going to open the library. You see those libraries are files like a Word document. So you can easily share them through Blackboard or any other application out there. I'm going to open one here that I did to show you that you can also put pictures beside the symbols. So you see how I've taken pictures from the internet and just put them like that beside the image. And the simulation is still going to work because my symbols are still being connected like that. And these pictures can be pictures of your own equipment that you have at school. And if you don't have equipment, take the picture online, it doesn't matter. But let me show you how it's done. It's very simple. Let's say I'm going to take a cylinder and I want to put a picture above it. So I'm going to go into the Home tab, choose the picture icon here. Again, you see my cursor change for a picture. I'm going to do a little square somewhere. And then the software is asking me, where's the picture? We support BMP, JPEG, PNG, so a couple of formats that you can do. And let's say I'm going to take cylinder parts. So you see the picture is here. It's pretty big, so I'm just going to shrink it a bit. And if I wanted to be at this size above it, I'm going to select both. I'm going to right-click, group them, go into your webinar library, and simply drag it here also. So you can have a library of all the components as you have them on your trainer that looks exactly the same in your library. So this is a very important feature, okay? And it helps them to know, like once I was with an instructor that was teaching in, it was process control in oil and gas, and he said to me, he says, all the components out there are kind of like explosion proof. So they look different than your typical component. So he said that he created a library with all these pictures like that. So when he was walking with the students in a field to do a visit, they were seeing components and they saw, okay, this is this, this is that. So they knew what it was. Okay, that's how these pictures really help. And then again, if you want, nothing stops you from putting the pictures on top of the symbol like this. And it's still going to simulate because the real symbols are behind the pictures. Okay, so this is something very interesting, and it helps a lot by providing this library to your students. So what I'm going to do now, we're going to create an electro-hydraulic circuit. So I'm going to build a relay logic circuit beside it to control that schematic. So first, what I'm going to do, I'm going to erase that. I'm just going to keep one cylinder for this purpose. Now I have I just want to say first, okay, that I just showed you the basic of the hydraulic here. There's a lot of advanced feature, a lot of different possibilities. And if you want to go more in depth in the hydraulic and you have more advanced questions, please, like I said at the beginning, feel free to take them down and send them to us afterward so we can answer them for you, okay? Okay, so to do my electrohydraulic circuit, I need to have a solenoid instead of that mechanical control here. So I can go look for it in the library, or I can simply double click on this directional valve, go into the technical specification, and here I can create any type of directional valve that I want. So if I click twice on the lever, I can change the command to the type that we have here. We have many of them to choose from. So I'm going to choose a solenoid, click twice. I can place it wherever I want. It does not matter with the simulation at all. If you want to change the spool of the valve, click twice on it, and then you're going to have multiple choices to choose from, okay? There's a lot of different possibilities. I'm just going to close it because I want to keep it the one that I have, okay? So now I'm going to check this box here. And now if I go back on my drawing, you see I have a solenoid valve with a question mark here because it needs to be connected to an electrical diagram. So right beside that circuit, I'm going to go into the electrical control library. Again, I can expand and go look through it, but for my purpose today, I have the component I require in the main section. So I'm going to click the 24 volt, drag it here, a 0 volt here. I'm going to take a normally open push button. When I drop the component, the software asks me for a name. So let's say PB1. You can put any type of names that you want, okay? It doesn't matter. I'm going to put a relay to show you how it works. So as soon as I drop my relay, it's going to ask me for a name. So CR1, for example. Now I'm going to take a normally open contact and drag it on here, just below, and I'm going to drop it. As soon as I drop it, the software is going to ask me, to which relay do I belong? I want to attach this to my relay CR1. So I'm going to filter here for C, and you see CR1 is here. The question mark on the left will automatically change to CR1 once I will double click on it. Double click, and you see change. And on my schematic now, you see they have the exact same name. So I'm going to drag out a solenoid here, and I'm going to call this A+. I'm going to connect all these components together. You see my A+ is a bit crooked, it's not well aligned, but since components stay connected, I can click on it, use the arrow on my keyboard, and just bring it up a couple notches like that. Now I need to link this solenoid to my A+. So click twice on the solenoid here. This time filter for A, and here's my A+. Click twice on it, and now you can see on my drawing, the A+ is there. So if I start the simulation, and I click here, I now have an electro-hydraulic circuit. But every time I go the push button, the springs push the valve back. So if you want the students to push only once and it goes all the way to the end, well, they're going to have to first latch CR1. So this will be maintaining the electrical signal to my CR1. But at one point, I want it to retract. So I can either put a proximity sensor on that cylinder or simply drag and drop a normally closed push button right here and name it, for example, PB2. Or let's name it return, for example. And then if I launch simulation again, I push once, the signal is latched, so the cylinder extends. And as soon as I'm going to open the circuit, it retracts. Push once, open, retracts. So this is why Automation Studio is good for the students, because it also improved the blueprint reading skills, because you always work with symbols. If the students makes a wrong connection, you see, for example, if he would have connected this here like that, we don't tell him something is wrong because we don't know what he's trying to do. But once he simulates, he's going to figure out that, oh, how come I can't cut the signal? So he's going to have to stop the simulation and make the changes to make it work. And also, if you don't want the students to do it this way, let's say, for example, you teach them that you want them to go like this. You want them to use a second line, let's say, for this here. If I want to copy this contact, I can hold my control key and just drag it down here like this. I can connect this ear and this ear. And if you want, I could have moved this like that and actually drag this return here. If the logic is good, it's going to work. Okay, so the students can come up with a different way, but if it works, it works. And then I'm going to click here to return. So this completes what I wanted to show you for the real logic. Okay, so this is how we do electro-pneumatic, electro-hydraulic circuits. Keep in mind something important. If you use electrical control here, you cannot measure voltage and current here. This is basically for creating control logic circuits. Okay, to measure voltage and current, we will show you how to do that in the electrotechnical module later towards in the presentation. So the next step now, I will create a basic pneumatic circuit, and I will control that using PLC. Okay, so I'm just gonna, let's say I want to save this work, for example. Okay, by the way, this is your 8.5 by 11 sheet. So I want to save it. So I'm just going to go click on the Automation Studio icon, project, save project as, and let's name it electro-hydraulic, let's say, and save. It's like saving a Word document. Okay, same thing when you're printing. If I click here and I do print, it's asking me what document I want to print, and I just do print, and that's it. Okay, so it is very simple on that part too. So let's erase everything. Delete. And now I'm going to drag and drop from the library just a basic pneumatic cylinder. So again, like we did before, you click, you drop it here. I'm going to take a 5-2 directional valve. I will connect, click, let go, click, click, let go, click. Then I'm going to put a pressure source here, an exhaust here. For the second exhaust, I can go in the library and drag it again, or I can hold the control key and just drag it here. You see the little plus beside my cursor? And when I let go, it makes a copy right away. I'm going to put my lines like this. And now it's connected. You see the question mark here is a bit off. If you want, you can just drag it under the solenoid just so it's more aligned with the right component. And if I want to test this, I can just go in simulation. I hit this and it's working perfectly. So now, because I have you see I have two commands here, a solenoid and a manual override that I can test. Or again, like I said before, I could have just clicked here directly on the spool. Okay. So let's stop this. I'm going to select and move it in the middle. I'm going to zoom out a bit. And now I'm going to drag and drop my input card. The input card are located in the electrical control library. The last item here called PLC card. So I'm going to drag out an input card and an output card. Then I'm going to drag also the rungs in the middle. You see it's not, I think it's not well aligned. So if I go like this, it's a bit up, so I'm going to click on it and just bring it down once down, just so it's well aligned. I'm going to go into the Allen Bradley section of the library, and I'm going to simply drag and drop the rung. This is where I need to put the program inside the PLC, let's say. You see it's a bit too wide, so I can click on the arrow here and just shrink it so it fits well in the middle. So let's zoom a bit more so we see better. So zoom window, I'm going to zoom in here, let's say. There we go. So I need to energize my card. So I'm going to drag and drop a 24-volt power source. I'm going to put a push button here because I want to trigger the first input by a push button. And again, I will name that. Let's call it start list this time. Okay. I can connect like this. And I need to put a 0 volt or common on my card. So I'm going to put a 0 volt here, which I can connect like this. So now if I simulate, I can actually energize my input 0 on my card. So now I'm going to do the same thing on my output card because now I want to energize a solenoid which will control this valve. So I'm going to go take the solenoid here, drag it on my out 0, and I'll call this A plus like we did last time. I'm going to hold the control key, copy the 24 volt here, hold the control key, copy the 0 volt here, and connect this like that. Now, like we said we did before, you see it's not underlined blue, so I need to link this with my A plus. If I click twice on the directional valve, when there's multiple commands like that, it could be confusing to know which one I have to associate. But you can directly click here on the solenoid, and then you're only going to have one choice. And I'm going to filter for A. You see A plus is here. Click twice. And now the link is made between these two elements. But I still need to run the logic in the PLC to trigger my output once I'm going to push on my start. So I go into the Allen Bradley, and I'm going to click here. I'm going to drop it here. And now I need to associate that with my in 0. So click twice on it. Filter for I. And here's in 0. Click twice on it. And now you see it's connected to my card E1_1 in 0. I'm going to click now. I'm going to need to energize an output. So I'll take this component. And I'm going to close this. This is just this. It's a transmitter element. You click twice on it. And you're going to link it to out 0. So filter for O. And here's my out 0. Click twice. And now it is associated to my out 0. So I'm going to connect these elements. I'm just going to bring this one like that on the side. Click this one here. And now if I start simulation, I have my circuit that works with the logic in the PLC. If you want to do a latch like we did before, I'm going to have to use an internal bit, internal relay, let's say. So I can actually hold the shift key down to disconnect this one because I want to put it a bit lower here. I'm going to drag out an output element here. But this time, because it's an internal bit, I'm going to replace the name transmitter by something. So let's say I'm going to name it, let's say B203/1. Okay, please, it's not the way it's written, I'm pretty sure, but it doesn't matter. Okay, you can make it to reflect exactly the way you want them to identify the internal bits. Okay, and then I'm going to put a normally open contact again here that I need to link to my B203. So click twice on it. Filter for B this time. And here's B203. Click twice. And now it is linked. And now it's going to latch my in 0. I want to add one of those contact here to energize my out 0 at the same time. So I hold the control key, drag it out, and it's going to copy it. Again, I could have simply taken another one from the library, but I'm just lazy, so I just hit the copy key, okay? And connect this here. And now if I trigger the simulation, hit start, the signal is latch. But I wanted again to retract like last time. But this time I'm going to put a proximity sensor on that cylinder instead of just putting a normally closed contact that I would change the status. So I'm just going to move it a bit to the middle. It's a bit off. I'm also going to bring up these components so it takes less room. So I can use my arrow to bring them up. And I'm just going to bring it down a bit more. So you see, you can very easily readapt your circuit after it's done. Now I'm going to go into my pneumatic library because I want to put a proximity sensor on that cylinder. So I'm going to come down here, take a proximity sensor, and drop it here. And I'm going to name this, let's say, A1. Again, the names, you can put whatever you want. Let me zoom in here. I want to show you something. You see, if I move this away, you see the diamond shape here? These are mechanical contact on the component. So I could have put it here if I want to read when it's in, but I want to read when it's out. But I'm not too sure where the out is going to be. So let's say I think it's here. But the way to extend the cylinder and see exactly where it's going to end, you can click twice on that cylinder, go into the data, and in here you can change the extension percentage of your rod. So I'm going to put it to 100%. And now if I go back on my drawing, you see I can just come here, position it well on the end, and click back on the cylinder and put it back to 0. And now it is perfectly placed. So I'm going to right click and zoom all component, but then I'm going to zoom a window because I want to focus more on what I've done so far. So I need now to put a normally open proximity sensor on my card. So I'm going to come here in the electrical control library because it's an outside element. And I'm going to take a normally open proximity switch. And let's say I'm going to put it on in2, for example. And I need to associate to A1. So again, I click twice on it. I go to variable assignment. This is where we do the assignment here. And I'm going to filter for A. and here's A1. Click twice on it. And now if I close, they are both linked together. So I'm going to connect this like this if I want. Boom. And now I'm going to trigger the into that to actually open and only close contact. So again, now I need to work inside the PLC. So I'm going to go into Allen Bradley, drag a normally close contact here. And I'm going to click twice to link this to my into. Click twice, filter for I, and here's into. Click twice on it. And now, if I launch the simulation, I hit start, it goes out and come back. But it moves a bit too quick. You know, it's hard for students to follow up because it just happens too quickly. So I can go in slow motion here. And when I hit start, you see it's moving a bit slow, but it's still like jerking a lot. Like it's moving like step by step like that. And I don't really like this way to do it. So what I'm going to do instead, I'm going to click twice on that pressure source. Because keep in mind, we can edit all properties in Automation Studio. And I'm going to shrink that hose so there's less air going out. So I'm going to put to 0.02 inches diameter instead of 0.2 inches. And now if I simulate again, you see now it's much more slower, so students can appreciate more what they've done and they can follow the sequence a bit better than when it moves too quick. Okay? But if you don't want the students to have to go on the pressure source, change it, and reduce its diameter, well, keep in mind, like we said before, you go in your library, you can create a main category called, let's say in this case, pneumatic, and you can drag this pressure source in your library. So next time a students do a schematic using your library, it will simulate right away at the speed that you want. Okay, so personally, I always reduce the diameter because I like it to a bit slower because it's fun to actually visualize what's happening during the circuit. And keep in mind, in simulation mode, you can also pause. So if I start here, I can pause the simulation and actually explain to the students, okay, look what's happening right now. This is clutch because of this and this and this. And then you can go and step by step, slow motion or just normal simulation and pause it again at a different step, okay? A lot of the time when I present a PLC like this, I have teachers telling me, okay, I understand the way you display your internal ID, for example, and I can, you know, it doesn't reflect really what I have on my PLC, but it's okay, I'm fine with it. But sometimes you really want to display the address. So I will show you how you can do this, sorry. Let me zoom in here so you see a bit better, okay. So I'm just gonna need a bit more, okay, I'm gonna tell that to you right away. You see, I need a bit more space on my page. I'm kind of stuck a bit, you know, and I want to do a bigger project, but it's kind of limited to what I can do here on my 8.5 by 11 sheet. So I can take an 11 by 17. I can take an engineering format. I can change the page size without any problem. But I want to keep my 8.5 by 11. So I'm going to right click anywhere on the white space of my page. And I'm going to click on Document Properties. If you scroll down here, you will see Component and Drawing Scale. This is where I strongly recommend that you change it. If, for example, I want it to be bigger, I'm going to click here and go, let's say if I go 50%, just to show you how big it's going to change. I approve. And now if I close, you see, this is still my 8.5 by 11 sheet, but look at the kind of circuit I can make on it now. A lot bigger, there's more room, and because I've changed the scale of the document and not the size of each one of them, when I'm going to drag out another component, it remains perfectly scaled with the other, okay? So this is something to keep in mind. So I'm going to right click and put it back to my 100% for now, because I can deal with it, no problem. 100%, close. And you see now, when I zoom my page or all my components, I'm back to my original format, okay? So let's go back to the address now. I'm going to move my 24-volt here so it takes less space. I'm going to take all my card here with the component and move them a bit on the left side like this. So let's say I want to display address. So if I click twice on this card and I go to the data here, you see I only have two choices. This is true, what I'm going to show you here, for every component in the Automation Studio. If you open it like that and you say, oh, I can't change this, why not? Look at the star here. This star, it's because they have pre-established some of the fields that would be more important than others that are displayed automatically. If you uncheck this star, you're going to see all the fields. Okay, we've put that star there because sometimes we've had comments from teachers saying there's too many information there. The students get lost. You know, can we just choose which one we want to display? Yes, you can. If you click on address here, you click on input number and you recheck that star, you see now those will be displayed by default. Okay, you can change it the way you want. So on my address here, you see it's kind of like percentage I, E1, blah, blah, blah. You can change that here. So let's say I want to display like an I column 0 and slash my input. I can check this box to display my addresses on my card. And when I close this, you see I have my I column 0 slash 0, 1, 2, 3, 4, 5, 6, 7 to the card. Because the card I chose, I have only 8 input. But if I click twice on this card, I can choose 8, 16, or 32 bit for that card. Okay, let's leave it for 8 for now. So I have that address now. This open contact, it's displaying the ID of Automation Studio. If you wanted to display the address instead, if I click twice on it, you see I can check this box to display the address on my drawing. I'm going to close this. You see the address is displayed, but because I have two, the software automatically puts it aside. So I'm going to click on this one and simply hit the delete key. I'm going to delete this one and bring the address on top like this. So this is how you can do it by displaying the address. You don't want the students to go and do what I just did because they're going to get confused, going to get lost, and you don't want to waste time with them. So keep in mind, again, the custom library, a great tool, like I said. I can go back in here. I can create another main category, let's say, called PLC this time. And in here, I can drag and drop this contact that is displaying the address in my library. So let's say I'm a student now and I need to connect something to my in3. If I drag this out here and I click twice on it, I'm going to go to variable assignment. I'm filtering for I, which is already there. And I'll click twice to in3. If I close, you see by default it's going to display the address. So that's why the custom library is so important. Even the card. Once my card is set up like that with the input and displaying the address, I can drag it in here. And it's going to have the address already written there. I have created a library like that for an instructor, which I have created inside examine if open or close, and I've put under it displaying the address. And on another one, I've put one displaying internal relays. So if you want this custom library that I did, just please feel free to send me a request in my email after we did the presentation, and I'll be more than happy to just share it with you, okay? Keep in mind, I just put a couple of components in there, but it will just show you how you can actually work with it, okay? Just so you know, also, you know, the star I talked to you about before, I had a customer asking me, he took a timer from the Allen Bradley library, he dragged it on the schematic, and once he clicked twice to change the time base, he went to the data here, and because the star was checked, you see, I don't even see that I can change the time. So if I uncheck that star, you see, I can change the preset time now. Don't ask me who decided which field to show by default, because for the timer, I mean, the preset time is probably the most important thing you want to show. But anyway, I just wanted you to be aware of that star, that sometimes you can just unclick it, so it just displays everything all the time, okay? So this is what I wanted to show you for the PLC. So now I'm going to move on and show well, before I move on, I want to show you something. Sorry, I just remember. We have virtual system in Automation Studio. The virtual systems are pre-animated machine for which the students only have to build the logic to control the simulation. Let me show you one, okay? So I'm just going to open. You see the software asked me to save this because I can only open one document at a time. But I don't need to save it, okay? So I'm just going to say no. And I'm going to open the drilling factory here. This one is controlled by a PLC. We have traffic light, car wash, elevator, you know, like a couple of them like that we've done. We have, I think, like a 13 or something system. So you see here, we have the virtual system on the left. And we have, if I zoom in my input cards, we have all the inputs and all the outputs. So let me zoom all components. So now if I launch the simulation, the logic in here will actually control my virtual system on the left. So here, there's no pneumatic or hydraulic involved. It's only some IOs, and just build the logic to control it. Like personally, if I was the instructor, I would have told the students, once the cylinder A is fully extended, I wanted to wait till C is retracted before A retract. Because you see now, when A pushes, C will be in the disk and A is retracting, which should make the disk to move. So they would have to change the logic. So basically what you can do, you can actually remove this here in the middle and provide the file to your students like this. So I can save this file like that. So when they're going to open it, they won't have to make all the links, inputs and outputs, blah, blah, blah. They can go right away, focus on the logic inside. So you can go by step. First step, let's just make A push that disk and hold it there. So they're going to go read the input 0. They're going to have to go read whatever is necessary to make the logic work. Okay, so these virtual systems, we have them already made. Some of them are controlled with the relay, like the ladder logic like that. Some are controlled by sequential function chart. So we have a mix of both, but you can open them, change them, resave them as you wish. Okay. So now what I'm going to do, I'm going to close this and actually start a new project to create a AC/DC motor control circuit. Okay. So I'm going to have to tell you something important. Okay. When you open Automation Studio, by default, it opens a page. Okay. This page is basically a document that would allow you to drag on it component from hydraulic, pneumatic, electrical control components, logic gates. You want to work with some gates. You know, if you expand here, we have AND, OR, and AND, so we have that library as well. Allen Bradley PLC, same thing. But look what happened when I tried to drag an electrotechnical component. It's like a DC source. You see? it does not allow me to do it. Because this requires a simulation of voltage and current frequency, and it needs another type of document to work with. You see we have a Project Explorer here on the right side, okay? This displays the document type that you have right now. Right now we have a diagram 1, which has like an hydraulic pump, which allows these components to be on it. So to drag an electrotechnical document, I'm going to have to use a different type of document. So let's erase those. I'm going to come here, document, click here, and then I can do a new electrotechnical diagram. Click here. The software asks me, do you want IEC standard or NEMA standard? Personally, I choose the default one because I can put both on it if I want, okay? And there's no map locators, nothing. It's just a white page, and that's what I want, okay? And now if I open the Project Explorer, you see I have two documents now, diagram 1 and electrotechnical one. You can have up to 10 diagrams in a project. So you may ask your students, on one sheet, I want you to draw the mechanical drawing. On another sheet, I want you to draw the electrical diagram, and move on like this. Every sheet can communicate between each other as well. Not a problem there, okay? So now that I'm on my electrotechnical sheet, you see I can drag my battery without any problem. But then if I go and I want to try to drag an hydraulic component, it won't allow me, okay? So just keep in mind that this is how it works, okay? So let me zoom in a bit here. I'm going to turn this battery sideways. So I'm going to right click on it, transformation, rotate, left. Then I'm going to go into my electrotechnical section here, into the basic and passive element, and resistor. I'm going to drag out a resistance here, 1000 ohm. I'm going to hold the control key. I want to put another one right here, but I'm going to turn this one sideways. So again, right click, rotate right this time. Or I could have just came here in the edit and choose position and just rotate here too, okay? Doesn't matter, same way. And then I'm going to hit the control key again to copy another one here. So let's connect all these together now. Click here, like this here. Connect this here. You see I have to double click. But in electrical, you can't split a wire in the middle to connect something. So the software asked me to which other component you're going to connect this wire. So I'm going to choose here. Same thing at the bottom here. I'm going to connect it here also. And you see the line displays in blue. You see all those numbers everywhere, wire numbers, port numbers. For me, I just want to get rid of them. So I'm going to go into the View tab here and uncheck power wire number, common wire number, and component port name. So it's more clean for me, okay? You don't want to have the 24 volt here as a battery source. Click twice on it and simply change it to whatever you want, okay? Same thing with the resistance. You want this one to display kilo ohm instead of ohms? Click twice on it and change it to kilo ohm. Here, for example, I want to be able to change that resistance on my drawing during simulation. So I'm going to click twice on it. I'm going to display the kilo ohm as well. And here in the parameter control, I'm going to choose a slider that would allow me to move it. And you'll see what it means, okay? When I close, now if I launch the simulation, I'll just do something first. I'm going to put a voltmeter, okay? So I'm going to go into the measuring instrument. You see we have a voltmeter, reactive meter, amp meter, watt meter, var meter, power factor meter. So we have a lot of different meters. I'm going to put a voltmeter here. There's an RMS voltage that's going to be displayed. I don't want to display the RMS voltage. I think it could be confusing for students. Click twice on the voltmeter and replace that RMS voltage by simply voltage. And then when you close, you see it's changed. So that's why I'm saying that the software offers a lot of different possibilities. So I'm going to connect this here. Click, because I want to do an elbow, and then click down here. Click once, click again, and click here. So now if I simulate, I have the voltage in the circuit, and I have the circuit simulating right now. During simulation, like we did before, I can go into the simulation tab and use these dynamic measuring instruments also. But the electrotechnical is pretty cool because I can actually use a multimeter. If I click here, the multimeter open. Then I'm going to click here, I'm going to put it to voltage, DC. And I can actually move the probe on a connection point. You see how my probe is going to come like a double line all around it? This is where I can drop it. So if I drop it here, take the black probe here, drop it here, and then you see I can see the voltage through that resistance. Let's move those probes to the other one. And now if I click on that resistance, you see there's a slider here. So I can change the value of this resistance and see live the affected voltage in the circuit. You want to measure the current? First, you need to open the circuit. So here you can go disconnect. I can click here and click there and actually come here and measure. First, I have to put the current. Come here and measure my current. And then I can just reconnect the circuit, and that's it. So this is how the measuring instrument work. If I stop the simulation here, and I want to put an AC source instead, no problem. I can just hit the shift key again to disconnect. I can go in my library in power here. We have converters, transformers, okay, bunch of information, but I can just click here and choose energy source, single phase, and take my AC here and just drop it on my schematic. And now I have an AC circuit. So as you can see, I can go here again in my basic and passive components. I can take inductors, capacitors, diodes, some LEDs. So be my guest, do RC or LC circuits the way you want. It's up to you. Okay? So this is how to manipulate the electrical technical. And now what I would like to do is I'm going to build a three-phase forward motor control. Okay? So I'm just going to erase all that and actually come out here in my library. And I know that everything I need, again, it's at the main source of my library, so I won't need to browse to the library. So I can take a source. I'm going to put, let's say like a circuit breaker right here. I can put the name that I want. I'm just going to erase it. I don't want any name to be displayed. I'm going to put an overload here. And I'm going to call this OL. And I'm going to put a three-phase motor right here. You see, by default, it displays the variable torque, speed, blah, blah. So I just want to display the speed. So I'm going to take this, delete, take this, delete. And on this one, I just want them to see speed. So I'm going to click twice on my motor. Like we did before, I go in data, and I'm going to replace. You see when I was saying there's a lot of field to choose from, so this is but I just need to look for one that's checked because this is displayed on my circuit. And I'm just going to put here speed, like this. You see on my circuit now, speed is here. I could have just erased the text, I would only see the RPM. But again, if you go in your library, you can drag the motor like this, so it already displayed only the speed, okay? In electrotechnical, I can click here and make my line one by one, okay? But I'm lazy again, so I'm just gonna go in here, ohm, and I'm gonna configure the polyphase wire to create an L1, L2, L3 wire. You know, if you click here, you can change what type of polyphase you want. And if I use now the polyphase wire, you see it's gonna make 3 lines at a time like this. So now if I simulate, I don't need the multimeter here. I click here, and you see my motor spins. But you see how it's going down very slowly because there's no friction, nothing. It's perfect almost. So if I click on it, I can add a bit of torque. And you see, oh, it drops much faster now. If I close, look how it's going to turn off. Boom, took about a second now. Okay, because we can change the torque or the load on the motor in simulation and see how this will affect the circuit. I will demonstrate that a bit later. So now what I'm going to do, I want to create a control circuit to actually push a button to start the motor go forward. Okay, so I'm going to drag and drop a transformer here, and I'm going to connect that on my circuit. So if I click here twice, again, the software asks me where I want to connect the wire. I'm going to connect it there. Click here, again to the left. And again, please don't judge me on my schematic. If you want to put the transformer before it's really up to you to decide, okay? I'm just like doing something. And you see that line now is became a regular line. I can right click on it and change it to a power wire. So it's going to be bigger like this. Okay? And now I'm going to drag and drop below here a control logic. So let's put the push button. I'm going to call this, let's say, start. And I'm going to drag and drop a relay contact here, coil. And I'll name this, let's say, forward. And on my 3-phase here, I'm going to drag and drop also a contactors pole. So I'm going to drag it again, as you remember, if you drag it directly from the library, I can drop it directly here, and it automatically connects in the circuit. Okay? So I will need to link that to my forward here. Click twice on it. Filter for F, and here's forward. Click twice. Now it's connected. So if I connect this together like this, if I start simulation, hit start, nothing happens because I need to close this first. And now I can start and release and stop the motor. But again, let's latch it. So I'm going to drag and drop a normally open contact here. And I'm going to link that to forward. You see my filter is already set to F, so click twice forward. And this is going to actually latch my start button. But again, I want it to stop, so I'm going to drag and drop a normally closed push button directly on the line from the library. And I'm going to name that, let's say, stop. You see the software asked me here, okay, because I inserted it somewhere, I'm going to reconnect this, there. So I just say, don't show this again. And I say yes, okay? But I'm going to also add now, if I'm going to click on this line and expand it like this, I'm going to put a normally closed overload sensor. So it's not in my library here. So I'm going to go into the control, relay contact, And I'm going to choose here a normally closed thermal overload contact. I'm going to drop it here. And I'm going to link that to OL because I named it OL before. You see OL is here. Click twice. And now it is connected to my overload. But I'm going to click twice on my overload because I want to change its setting to 10 amps. So I'm going to go into the builder and I'm going to set a thermal current setting to 10 amp here instead of 16. Okay, you can go and edit the tripping curve if you want. Okay, there's a lot of things that you can do here, but I just want to stay to the current rating and that's it. I approve. Before I do that, before I go out, I'm going to come in the data here because I want to display on my circuit the tripping countdown. And I'm going to go back here because I want to display also the current setting. So I approve. And now on my overload, you see I have the time display here and the 10 amp, which is a setting of the overload. But this time I want it to be big. So let's go edit and let's increase the font on it and align it to center. So you see now it's going to be bigger, and I can even change the color if I want. Everything is configurable. Okay. So let's start the simulation again. I'm going to close this and I'm going to start the motor. Everything spins, it's latch, everything works fine. I'm going to take a clamp meter and I'm going to take the current on that phase here. 4.25 amp. Okay, sounds pretty good. But what if I click on the motor and I increase the torque on the motor? So let me just move this first a bit up like that, okay? Just so you see. So I'm going to click here. Let's increase the torque. You see, as I increase the torque, the current goes up. When it go above, now it says it's going to open in a minute 16 seconds because the current is up. If I go higher than that, well, I went very high now and it just opened up. And I can't start it again because my overload has tripped. So if I stop the simulation, let's try to do it a bit, not that quick this time, okay? So let's fire this up, start simulation, go back here, put the phase here, bring down the torque. You see, the software saved my torque setting that I had before. So when I relaunched the simulation, it tripped almost already because I didn't have time to bring it back down. Now I'm going to put it down. So when I'm going to start the simulation again, it won't happen this way. You see, if I close this and I start, it's still counting down because it's a bit high, but I'm going to bring it down so I'm going to have time to show it to you. Okay, so now my current is set at just barely over 10. And when I go a bit higher now, you see it start counting to about a minute. And let's put that to 19 amp, 31 seconds. Let's put it to 21 amp, 15 seconds. So let it go to 15 seconds, and it will show that this will open this overload contact, which will actually stop the simulation. And there you go, everything stops. So this is how we actually create circuit in Automation Studio, drag and drop, change the properties of the components. Again, the customizable library, for me, I think it's really important. You see, for example, this motor. Let's create the category here very quickly and call it, let's say, motor control. And let's create a subcategory to this one called, let's say, forward control, let's say. And I can simply drag and drop all my components in here like this. So again, students don't have to go anywhere else than just focus on that library. Every component can be here. I can put all my start buttons, my transformer, everything is here. Okay, so that's why I really love this feature because it just simplifies the life of a lot of people. So this is what I wanted to show you today. I know we scheduled 2 hours, but this is the time that I think we went over what I wanted to show. Like I said this is the basic introduction to Automation Studio. If you have more advanced questions, if you have any other request, please send me an email. If you're from the United States, USA, I'm your contact. If you're from Canada, my colleague George will be your contact, but this will be also written in the email that you'll receive. So please don't hesitate. Also, if you have any comments on the training we did today, we're always here to try to improve ourselves, so please let us know. And if you have any recommendation on what other type of webinar you would like to see and go more in depth in a specific module, please let us know as well so we can plan other webinars down the road. So thank you everyone for being here today.